Hi, let us have a quick understanding on various components of Spark and how Spark-SQL fits in along with other components within Spark. Within Spark, we have Spark Core, which is going to be the base platform or the base component for all the subcomponents, which works with the low-level API called RDD, Resilient Distributed Dataset. On top of it, we have all the subcomponents, Spark-SQL, graphics, MlLib pipelines, Spark streaming, and structured streaming. Spark-SQL is what this particular course is about, where we are going to handle structured data. Within Spark-SQL, we have high-level APIs like Dataframes and Datasets. As we discussed earlier, Dataframes are like a collection of rows distributed across multiple systems, which can exist within the memory. And Datasets, very similar to the Dataframes, but each and every row is strongly typed using the case classes. And Spark-SQL internally, it has a catalyst optimizer to optimize any query that we are firing against the structured data to find the optimal physical plan and the logical plan. The catalyst optimizer going to work on the optimal physical plan and the logical plan to get the result faster with less I/O and with very low latency. It has an ANSI SQL parser where we can use the normal ANSI SQL. The ANSI SQL parser going to parse the SQL queries and get that executed within the Spark. We will discuss more in detail about the catalyst optimizer, the high level and low level APIs, ANSI SQL parser, all that in further sections. And within Spark, we have other subcomponents like graphics, which is going to work on the graph processing of interconnected data. It basically works with the graph theory. And Spark-SQL can interact with the graphics as well. And it has another subcomponent called MlLib, where it has a list of machine learning algorithms, which will facilitate the data scientist to implement any machine learning algorithm on top of any dataset. And Spark-SQL can interact or make use of the MlLib when it needs to be applied against any structured data. And along with that, we have another subcomponent, streaming, where it can be used to handle any streaming data, whether it could be a structured streaming or unstructured streaming data. And Spark-SQL can interact with the streaming for structured streaming data processing. And for all this type of processing, we need the data to be available within the Spark. Spark can get the data from various sources, like it could be a file system or an RDBMS or NoSQL database or any messaging system or any data engine. It can read the data as well as it can write the data. So most of the time the processing going to be, it's going to use the file system or RDBMS or NoSQL or messaging system as a data source, read the data, partition it, divide it, distribute across multiple systems, do the processing either using Spark-SQL or MlLib or graphics, and extract the required information out of it, and the result it can be written back into RDBMS, NoSQL or a file system or any messaging system. And almost it supports every file systems, file types like CSV, JSON, zip file, Excel file, Avro, Parquet, sequence files. When it comes to the file systems, when it comes to RDBMS, it can connect to any RDBMS as long as it has the driver and the connection informations, and almost every NoSQL databases it can interact. And regarding the messaging systems, it can interact with various type of messaging systems, especially like Kafka and Redis, it can interact. We are going to see examples for each of these data types and the data sources we are going to see in detail. So at the high level, the main interaction is going to be through these two type of APIs, either high level API or low level API. So within Spark-SQL, we will be using the high level API, either Dataframes or Datasets, and we can make use of the low level API as well from the Spark core when the data needs to be converted into structured data from the unstructured data form. And within the low level API, mostly we will be handling with RDDs, that is Resilient Distributed Dataset. It has the property to exist in the distributed environment, as well as it has the property of resilience. That is, Even if the data is lost, it knows from where to regenerate back.